Exercise 6 is a really good example of pretty much anything I could ask you on a test about this experimental lingo, so to speak. So if you have a moment, try this on your own. If you want, you could scroll, like just go to the very end of the video and see how you did. And then if you had something wrong, just go back, figure out what you had wrong and go back and watch my explanation. So hopefully you tried this before you're watching it, but we've got this situation with these t-shirts, and the first thing we're asked to find is the response variable. So the response variable is what we measure at the end. Right? It's our outcome. So if we're looking for what's measured at the end, we can see at the end there's a level of cleaning for each shirt is recorded. So we're going to put that down as our, you can do cleanliness level, you could do cleaning level, anything like that is fine. I had some really good questions in my other stats classes about potential issues here. I had some people say effectiveness of the laundry detergent. Well, that this is sort of a proxy for that. It's not what was recorded, right? What was recorded was this cleaning level on a 1 to 10. So if you would put the effectiveness of the laundry detergent, I wouldn't give you full points. I might give you some because it is what they're trying to get at with this measurement, but try to stick with what is recorded at the end. And the fact that we have this recorded level of cleaning is telling you that's our response. Another mistake I saw in my other classes were students writing the word average cleaning level because they saw this, right? That we're going to record the average cleaning level at the end of this. That's not what's recorded. That's what's calculated at the end. So that is a misstatement, right? You don't want it to say that we're finding the percent or finding the average or finding the number unless that's actually what we're recording for each and every observation. So that was a mistake and would dock you points if that was on the exam. So don't make that mistake. I'll need the green back. All right. So our explanatory variables are also called our factors, right? These are what we are manipulating or what we think might influence the response variable. So we look and it looks like we have some random assignment, which is letting us know that we're dealing with an experiment, which we knew, to 1 of 3 water temperatures and 1 of 2 wash cycles. So there are our explanatory variables. We think that the water temps and wash cycles are our, did I say think? We know that those are our explanatory variables or our factors for this experiment. Again, some mistakes that I saw and want to highlight from my other classes. A lot of students wanted to write something down about this organic laundry detergent. They really wanted to put the organic laundry detergent somewhere on this page. But the organic laundry detergent is not a treatment. They only use the organic laundry detergent. This wasn't comparing it against something else. It was almost like they were trying to write the label for the back of the detergent to tell people what to use in terms of a wash cycle and a water temp. So the only things that we're manipulating, that we're looking to see how it influences cleaning level, are the water temps and the wash cycles, even though we are doing this overall test of effectiveness of the laundry detergent. Don't get distracted by that. All right, another thing I saw was students wanting to write down the levels of these factors, right? The water temps were cold, warm, and hot, and our wash cycles were regular and delicate. These are the levels of those factors. They are not the factors of the explanatory variables themselves, so you don't want to write them, right? The explanatory variables are the things where, oh, these are the 3 different varying things that we could have recorded. Our number of treatments, got a lot of mistakes here. A lot of students want to write 2 or 60. The number of treatments is 6. Because remember, your treatments is every combination of these different water temps and wash cycles. So when you're putting a shirt in the, and I've had a student in one of my classes say, well, what about just plain water? I'm like, if you're putting a shirt in the washing machine, you have to tell it what temperature that water is, and you have to tell it what wash cycle to use. So there's no such thing as like a control group per se in this setting. We have all of these different combinations of the water temps and the wash cycles. So it's just going to be the 3 different temperatures times the 2 different wash cycles. And that's how the treatments will always work. In fact, if you looked up a factorial design, which I mentioned way up above when we talked about experimental designs, Factorial designs are just that. You start with what are the water temps, and you put them in one of those three groups, and then you put them into the 2 wash cycles. And you could do that with more than 2 factors, right? And so each time it just multiplies, which is why they call it a factorial design. All right, last question that we have to fill in here is the experimental units. These are the white t-shirts themselves. Here, if you included the 60 or didn't include the 60 on a test, I would give you either one will be fine. But these 60 white t-shirts are our experimental units. I put the 60 in parentheses because I wouldn't have docked you if that had been left off. The average level of cleaning, that last piece that was calculated, right? That's going to be calculated from our 60 t-shirts. These t-shirts are a sample. This is not every white t-shirt ever, right, to use this laundry detergent. So that's going to be a statistic. And the last piece, we saw that the person evaluating the cleaning level was unaware of which treatment it had gotten. And the reason we would include that is because we want to make sure that we're reducing that observer's bias, right? Rating the cleanliness, reducing bias of the evaluator. If you think about rating the cleaning level or the cleanliness of a shirt, it's a very subjective measure, right? You kind of just glancing at it and saying, yeah, even if you had a little like matrix of different colors of grass stains and like super clean to not so clean, and you had numbers associated with them, there's still going to be a measure of subjectivity to it. And so most of us, I think, would think the hot water is going to do a better job of cleaning. And if we know the shirt came from the hot water, we might just see it as a 6 instead of a 5 or whatever. I have no idea how this rating system is going, but hopefully you get the idea. So anyways, yes, like I said in the little note below the video before, I really like asking about response and explanatory variables. The other pieces here are a bit lame, but identifying which one is which is super important.